FMP stands for Fluid Mixing Processes, and it's a consortium project that we've been running here at Framatome BHR since 1983. It's a big project funded by companies across a wide range of industries, everybody from pharmaceutical companies to personal care, petrochemicals to agrochemicals. And because there's lots of shared interests between member companies, they get more value for money because the program's much bigger than it would be if they were funding the work themselves, using industrially relevant geometries, process conditions, and can be related directly back to processes that people are trying to develop across the spectrum of the members. The main benefit of FMP is that it helps speed up process development, scaling processes up where processes need to be taken from the lab before then moving up to full-scale production on plant. Probably the main deliverable from the consortium is the Excel design guide. It's a tool we've developed using Microsoft Excel so all of the member companies can use it across their business, and really all the data and all the correlations have been distilled into that predictive tool, which makes doing all sorts of scale-up calculations and comparing systems incredibly quick and easy to do, and access all the confidential information that's not available in the public domain. It allows people to predict what's going to happen in advance. It tells people these are the conditions we need to run our process under to get the right product, but it also gives prior warning when things won't work and saves time because you don't waste time operating under conditions where you would lead to a dead end. They also get access to all the data and all the information and knowledge that's been generated since 1983. Huge amounts of that still completely unique and very directly applicable to industrial processes and simply isn't available anywhere else. We do training for member companies and developing company expertise in mixing. Developing that knowledge is a critical benefit of FMP membership, so the training course is there, customized for that member's interests to make sure that they're aware of the information that's most relevant to them. We also do consultancy for member companies, and the consultancy we do is completely confidential to that customer. We can work on any process they're interested in, doing experiments, doing calculations, providing advice, and that's a really critical benefit for a lot of companies who don't have access to their own laboratories sometimes, or the experimental techniques we've got. We have a steering committee meeting where we present all of the potential work we think we could do in the upcoming year. Then there's a voting system, so all the members explicitly put forward their contribution for what work they think is relevant, and we use that to determine the work programme that all the members' opinions are considered equally. The consortium experimental work covers stir tanks, jet mixers, and also inline static mixers, where there's a very little information in the public domain, but they're a very important processing tool. We work with processes which have single phase, liquid phase only, and gas and solid and liquid dispersion processes. One of the great things about the experiments we do in the lab is because we use simulant fluids, we can actually see what's happening, and it's very useful for members to get the opportunity to see what's happening inside their reactors. FMP have also got a lot of experience using computational fluid dynamics. It's not the core part of the FMP program, which is focused on collecting experimental data and developing scaling rules and such like with it, but we do use CFD to complement the program when it's particularly relevant. At FMP, the engineers are all really interested in solving industrial problems, doing experiments, doing calculations, providing advice. People need to be able to, as quickly as possible, get the process back working again, making the right products.